sand filter certainly eliminates the need for a lot of these pre-treatment devices and other things that are supposed to get some of the pollutants out of the water just by filtering it through that sand bed you hear in that schematic, and then everything just perks through the sand into that perforated pipe, and out goes clean water. It's really that simple. So, and this was the design of our sand filter. It looks much like a stormwater detention or retention system, which it is because it stores water as well. What you see here is two different size pipes. The sand filter itself is 84-inch. You need room for somebody to get in there and do whatever maintenance is necessary at some point. And over the years, we've gotten in these, or contractors or other people have, and they find there's really not much maintenance to do. Sometimes a crust forms over the top of the sand bed layer, and they like to rake that a little bit, but usually everything's always working after a number of years. I've never heard any stories of any real maintenance required on these, but it's going to go through and perk through the sand, like I mentioned, through the under drain. It's going to outlet into the top portion of what we're looking at, which is a 60-inch diameter, fully perforated, which means we're not putting the water back into the soil. We're not recharging the groundwater. We're just storing it and releasing it, classic detention style. And so what made this job a little unique, it was originally specified as storm tech chambers. And you can see those red circles on either end of that system. Those are pre-treatment devices that were required to kind of get some of the sediment out of that flow before it got into the isolator row. And this is a Virginia DEQ kind of nuances that we're looking at on this screen. They give some credits to how we're treating, and it all boils down to how much phosphorus we're able to remove from the effluent, and that is able to give some credit to the developer, and it might free up some more land for them to do more impervious area. So it's kind of a big deal to get better credits in Virginia. And so with the original design, they're able to get a total of 50% phosphorus removal, and that's 10% from that pre-treatment device, and then the isolator row gets an additional 40%. And what we're looking at here really is two different systems, flow coming from the left, flow coming from the right, two different drainage areas. But in effect, they're getting 50% removal total from each of those, the way it's laid out here. And so what we did is we get rid of the pre-treatment device, in effect, and we're just using a sand filter. Virginia DEQ gives us 60% credit, sort of a something that's been worked into their regulations over the years to kind of recognize the performance of sand filters. And I've circled sand filter number 1 and sand filter number 2 to kind of coincide with the previous slide where we saw flow coming from the left and from the right. There is a common outlet into the 60-inch system, and bada boom, bada bing, 60% wins the day, gets the job, and we're able to take and swap out that chamber system for what we're looking at here. And so treatment credits, nutrient credits, all kinds of good stuff the DEQ looks for and the developer wants to, it really liberates him from some of the restrictions, giving him more options on how he can develop his site and maximize the site use, and all from that 10% advantage, really. Some of the finishing touches include sealing up some of the inside joints of the detention system itself. I mean, that's a Virginia DEQ requirement, and over the years they've gotten comfortable with the method that we've been using or who we outsource this work to. There's really no testing required at this point, and they've employed this kind of a service a number of times that we were involved with anyway.